All right, we're back. We're doing compositions of trig functions and inverse trig functions, which I find these problems kind of fun. Once you've memorized kind of the puzzle pieces, it's all about like figuring out which piece goes where. But if you're not memorizing things, these are probably an unmitigated disaster for you. So just memorize them. Like it's not really that bad. So here we go. We got compositions of more than just two functions. So I'm going to go through it a piece at a time and see what I can do. So first thing here, I want to find the inverse cosine of the sine of the inverse tangent of negative root 3 over 3. I recognize that. So the first thing I'm going to do is deal with this. And that means this is going to be equal to the inverse cosine of the sine of, well, what angle is that? So it's either from the first or the fourth quadrant. I don't know why I'm not drawing, because this is the killer thing right there, is if you draw that, you will get this right. It's tangent and it's negative. It's from here. Root 3 over 3 means it's a pi over 6 angle. So it's got to be negative pi over 6. So we want this. So this came from this. I'm going to try to color code this. We'll see how it goes. So now I need to figure out the sine of that. So this is going to be the inverse cosine of, what is the sine of negative pi over 6? Sine of negative pi over 6, you can think of it any way you want. You could think of the sine of 11 pi over 6, because 11 pi over 6 is coterminal. You could think of sine is odd, so it's going to be the negative of the sine of 11 pi of, what am I even saying? It's going to be the negative of the sine of pi over 6, because I'm using even odd properties really. So the sine of pi over 6 is 1/2. The negative of that is negative 1/2. So we get this. So this came from this. I don't know if that's good color coding. I mean, I guess it's all right. Now, cosine inverse of negative 1/2. We could draw. I have them memorized, which I think is what you should also do. But even when you have them memorized, it doesn't hurt to draw. Like here's negative 1/2, which would hit here. You can see it's like above 3 pi over 4. Everything is based on the pi over 4. So it's above or below it. It's above it. It's going to be 2 pi over 3. So this, this whole thing, 2 pi over 3. If you type in these problems exactly as they show up on paper in your calculator, it will just spit out the answer. So that's a great way to check, and you should definitely do that. All right, let's see if we can do this. So we never talked about inverse secant, which is not a huge problem. It would be a problem if it was negative, the inverse secant of a negative, and we're not going to talk about that right now, but that's like an issue. There's no consensus. Although like technology has kind of solved that. Maybe it didn't solve the problem, but it like technology voted and technology decided on what the inverse secant of a negative should be. But the one thing to keep in mind is every positive ratio definitely comes from the first quadrant. So I know that this is a first quadrant angle. If you don't like the way this is written, let's think about this. So here, this is an angle, right? So I'm going to call that angle theta. I'll say theta is the inverse secant of 2 over root 3. So what does that mean? That means that the secant of theta is 2 over root 3. But like maybe you're not super familiar with that. Well, take the reciprocal. The cosine of theta is radical 3 over 2. So look at this question. What we're really being asked is this, I'm going to rewrite it. It's the tangent of the sine inverse of the cosine of theta, because that's what we made theta, right? This is this. So far we have this. Well, I just figured out actually that the cosine of theta is this. So if I find this, now I'm doing the tangent. So you gotta like look for these things as you go. Of the inverse sine of the cosine of theta, which is root 3 over 2. And I think we're probably in pretty good shape. So now I have this memorized. You can also draw it. You can draw it and have it memorized, probably the optimal thing. So sine is the y coordinate. So the y coordinate's like up here. So what angle is that? That's got to be pi over 3. So we're doing the tangent of pi over 3, which we memorized is root 3. So you can work your way through these in a lot of ways. There's not one right way. There's a lot of wrong ways. And there are a lot of right ways. So, but you just do it, right? You just kind of like think it through. So here, I don't know, I feel compelled to highlight this part. I used this picture for, and it gave me this value. And then tangent of pi over 3, you just have to memorize. It's a pi over 3 angle. It is pi over 3, so it's just root 3. Let's try this next one. So it starts out like you'd expect, but then something happens. Let's find out what. So first thing I'm going to do is I'm going to say this is the sine of the inverse tangent of the cosine of. This represents an angle, and it's actually an angle that I know, just written weirdly. That is pi over 6, right? Inverse sine of 1/2, definitely pi over 6. 1, 2, 3, 1, 2, 3. Sometimes I count. So when there's a lot of parentheses, I'll count the openings, 1, 2, 3, and then you have to match them up with a closing, 1, 2, 3. So like when you go through, you can tell if they're mismatched. If they're not all like sitting at the end, it's harder to like identify it when it's wrong, but you can still do it. So sine of tan inverse of, what is the cosine of pi over 6? It's root 3 over 2. So now there's a problem, because now I need to evaluate to move further in this problem, I need to evaluate the inverse tangent of root 3 over 2. Root 3 over 2 is a famous ratio, but it's not a famous tangent, which means this is not an angle that I know. It's an angle, right? Like the angle itself is the inverse tangent of root 3 over 2. You will never get a better answer than that. You can get an approximation, which you might prefer, but it's not more accurate. So what I'm going to do is I'm going to say that this is theta. I'm going to say theta equals the inverse tangent of root 3 over 2. So you can use this anytime there's an inverse trig function that you're a little uncertain of. Call it theta, write it down, see what happens. So I'll take the tangent of both sides. Tan of theta is radical 3 over 2. All right, I still don't know what that is, but if the tan of theta is radical 3 over 2, then I can definitely draw a triangle. If you remember, we've done something like this before. I don't remember where, but at some point we solved a bunch of composition things by drawing a triangle. And I'm going to do that right now. So this, wait, let me auto triangle here. Nice. All right, so theta is there. The tangent of theta, so this theta, different color, man. Got like all the colors of the rainbow with you, and you're just going the same way all the time. That's gonna be that. I know that the tangent of theta is radical 3 over 2, so opposite over adjacent is radical 3 over 2, which means I can find the hypotenuse, right? It's gonna be the square root of radical 3 squared plus 2 squared, which is the square root of, I don't know what that is, 7, square root of 7. So that's the hypotenuse. And then what am I looking for? Well, if theta is, well, so I gotta highlight this in multiple colors. Theta is also there, right? So this problem is saying find the sine of theta. But from the triangle, I can see that the sine of theta is opposite over hypotenuse. So it must be radical 3 over radical 7, which you might be inclined to rationalize. If you want to rationalize that, that's totally fine. I don't want to, because I hate rationalizing, and I feel like it very rarely gets you anything that you didn't have before. But let's go to the calculator and just like see what happens. So I'm going to do the sine of the arctan of the cosine of the arcsine of 1/2. Calculator's going to rationalize. But you see, so what happened is you have square root of 3 over square root of 7. It multiplies the top and the bottom by the square root of 7. Square root of 3 times the square root of 7 is square root of 21. So that's where that comes from. But we got it. We got it by drawing a triangle. When you run into an inverse trig of a ratio that's not famous, that you don't recognize, draw a triangle and use the triangle. And that, I think, is pretty much what the next page is going to be about. So I'm gonna end the video here and come back and do that. This is a huge idea. So we're going to be drawing triangles every time we hit a non-famous angle, ratio, I guess. Ratio or angle. we will draw a triangle. You're never really going to draw a triangle that has like pi as a side. I see people do that all the time. It like blows my mind. Like you're going to draw a triangle that has a side of pi and a side of 6. Like, what are you doing? But anyway, I'll be back in the next video where we will do some triangle type things, I think, which I really love. So I'm excited for that. So see you there.